All right, problem number 21. Water is pumped into a tank at a rate modeled by W of t equals 2,000 e to the negative t squared over 20 liters per hour. Find the instantaneous rate of change of W at t equals 6 and explain what your answer means. Okay, first of all, we need to read into this a little bit. It says to find the instantaneous rate of change of W. Instantaneous rate of change is the derivative. So basically what this problem is asking us to do is to find the derivative at 6, all right? This is a calculator active problem, which means I can use Math 8 to get my derivative. So I'm going to plug this function into y equals, and then I'm going to use the Math 8 feature. When I do that, I'm going to get negative 198.359, so that will be it rounded to 3 places. And the units on there, if I started with liters per hour and I'm taking the derivative, it is going to, it'll be liters per hour, so it's going to actually be liters per hour squared. Okay, so now it says explain what your answer means. So W prime, a derivative, is always something is changing. Well, what is changing? W is changing. Well, W is a rate, so the rate of water being pumped into the tank is changing. So the rate at which water is being pumped into the tank, okay, it's changing. How is it changing? Well, the derivative is negative, which means the rate at which water is being pumped into the tank is decreasing. And how fast is it decreasing? It's decreasing at a rate of 198.359 liters per hour squared. Again, you're asking what is changing? Is it increasing or decreasing? And how fast is it increasing or decreasing? Okay, problem 28.6. Use the linear approximation for f of x equals 3x squared minus 4x plus 5 at x equals 1 to estimate f of 1.1. So we need to understand what this is asking us for. Linear approximation is a tangent line. So it's asking us to use the tangent line to approximate f of 1.1. Well, remember, how do you get a tangent line? In order to get a tangent line, you need the slope and you need a point. So let's do both of those. First of all, if I want the slope, I need f prime, and f prime is 6x minus 4, and I'm approximating it at x equals 1, so f prime at 1 is equal to 6 times 1 minus 4, which is equal to 2. So that is my slope. And then if I would like my y value, my f, we know that x is 1, so when x equals 1, we're going to find f of 1, and if I plug 1 into that original function, we will end up getting 4. So that means that y is equal to 4. All right, so then from here we're going to go ahead and make our line. Two different ways you could do this. I'm going to actually do both ways so you can see each way works just fine. I'm going to first of all use my y equals mx plus b method. So if I plug in 4 is my y, 2 is my slope, 1 is my x value, b, I'll get 4 equals 2 plus b, b will equal 2. Okay, and so my equation is y equals 2x plus 2. Another way that I could tackle this problem is just use y minus y1 equals m x minus x1, which is probably my preferred method for this problem. I'll have y minus 4 equals the slope, x minus 2. And then I probably, on this one, I just add 4 to both sides. So I'm going to have y equals 2, x minus 2 plus 4. So both of them give me my equation of my tangent line. And then it says to use that to approximate 1.1. So we're just going to now plug 1.1 in for the x. So y equals 2 times 1.1 plus 2. If I worked this method, it would be 2 times 1.1 plus 2 plus 4. I could leave my answer like that. If you actually worked it out, you should get an answer of 4.2. Right, 28. A cylindrical container must hold 2 liters or 2,000 centimeters cubed of liquid. Find the dimensions of the container R and H, which will minimize the amount of material needed. So this is an optimization problem. We want to minimize the amount of material. So that is what we are going to be taking the derivative of. We need a formula for the amount of material. So if we've got this cylindrical container, it doesn't say the top is off, so we're going to have a top and a bottom, and then we're going to have this material around. So I need to figure out a formula for that amount of material. So I'm going to put amount of material. Okay, I notice I have a top and a bottom. They are both circles. The area of a circle is pi r squared, and there are two of them because there is a top and a bottom. Okay, and then I'm going to have plus, and then from here, if I'm just going to draw a little picture over here, if I were to think of this as like a soda can or something like that, if I were to take, or soup can maybe, if I were to take the label off, this would form a rectangle, and I need the area of that rectangle. I can notice that the height of that rectangle is going to be h, and then the this part of the rectangle is actually the circumference of the circle, which I know is 2 pi r. So the area of that rectangle is going to be 2 pi RH. So I have a formula to take the derivative of. I do notice that I have two variables in here, and when I'm taking the derivative I really only want one variable. So I'm going to go see if I can find some information to take a little side trip. So let's see my side trip. It tells me that my container is going to hold 2,000 centimeters cubed of liquid, which will be my volume. So I'm going to write a volume formula. The volume of a right circular cylinder is pi r squared h. All right, and then from here, I know that the volume is going to be 2,000, so 2,000 equals pi r squared h. I'm going to solve this for h, so h will equal 2,000 divided by pi r squared. All right, so now I'm going to plug that into this formula. So now I'm going to have a equals 2 pi r squared plus 2 pi r, and then instead of h, I'm going to have 2,000 over pi r squared. Okay, and I'm going to be, before I try to take the derivative of this, I'm going to try to simplify this. The pi's are going to cancel, one of the r's cancels, and then 2 times 2,000 is 4,000. So notice this will be 4,000 over r, but I'm going to make it r to the negative 1. Okay, I am now ready to take the derivative. So the derivative of 2 pi r squared is going to be 4 pi r. The derivative of 4,000 r to the negative 1 is negative 4,000 r to the negative 2. I'm going to rewrite that as 4 pi r minus 4,000 over r squared. Whenever we want to optimize something, we're going to take the derivative and set it equal to 0. So take 4 pi r minus 4,000 over r squared and set it equal to 0. I'm going to add this to both sides, so I'll have 4 pi r equals 4,000 over r squared. Now I can cross multiply. So that 4 pi r cubed equals 4,000. I'm going to divide both sides by 4 pi. That will give me r cubed equals 1,000 over pi, and then to get r, I'm going to cube root both sides. So if I cube root 1,000 over pi, I get to 3 places that the radius is equal to 6.828 centimeters. And it asked me to find the dimensions, so I found r. I now just need to find h, so I'm going to go back into my side trip, and I'm going to plug r right in here. If I do that, I'm going to end up getting h equals 13.655, and that would also be centimeters. So I found the dimensions of the container, which will minimize the amount of material needed. I probably would give you the formula for the volume of a circular cylinder. I don't think that I would give you the formula for the amount. You'd have to figure that out yourself. Okay, 29. If f of x equals 2x squared minus 4x for x is greater than 0, find the derivative of the inverse of 16. So hopefully you remember the formula for the derivative of an inverse. It's 1 over f prime of f inverse of your x value. Okay, and then we're just going to work this out. The first thing is, in here, we want the inverse of 16. Well, if 16 is the x value on the original function, it's going to be the y value on the inverse. So we are going to plug 16 in for our y value and solve for x. I'm going to set this equal to 0, so I'll have 0 equals 2x squared minus 4x minus 16. I'm going to factor out a 2. Okay, and then I notice I'm going to divide both sides by 2, so I'll still just get 0 equals x squared minus 2x minus 8. I'm going to factor that. That will factor as x minus 4, x plus 2. And then my two x values would be x equals 4 and x equals negative 2. It does tell me up here that x is going to be greater than 0, so I can get rid of that choice. So I have now found that that answer right there is 4. So my new setup is going to be 1 over f prime of 4. And then from here, f prime of 4 is the derivative at 4. So f prime is equal to 4x minus 4. So now I'm going to find f prime of 4. So it'll be 4 times 4 minus 4, that will give me 12. And so this whole answer gives me 12. So my final answer is going to be 1 over 12. So that's the derivative of my inverse at 16.